I can't believe I haven't covered this a long time ago. Now you may be laughing, but please hear me out right after this. By the way, behind me is Gem Lake, which is very close to where I live, and I'm thinking I'd give you something nice to look at while I ramble on and dream of the upcoming hiking season. Attribution is in the video description below. Anyway, where was I? Oh yes, so I've been reading with shock and awe about the age verification laws and the impact they might have on our favorite Linux distributions. I've been on Fedora Silverblue for years, and came to the conclusion that at least for open source, volunteer-driven, decentralized, and with no registration of user accounts connected to these projects, it will be more than a challenge for any meaningful government enforcement, especially for distributions like Arch and Debian. Even so, it got me thinking about how to make things more difficult for nosy people wanting to audit how I run my systems. So naturally, I started looking into how I would set up a core Linux system built on full disk encryption and secure boot, where the recovery key, or passphrase, is enrolled in the trusted platform module with an unlock pin, while measuring changes in the machine's firmware and secure boot state, hopefully making both brute force and evil maid attacks much more difficult to carry out. I can't believe I haven't already covered all these concepts working together on this channel, so now is the time, and why not use Arch Linux and configure everything the Arch way? The official Archinstall script on the ArchISO is, in my opinion, well, it is, woefully inadequate to the task we have set before us, so we only have the good old manual method. The goal in this video is to install Arch Linux from scratch on a KVM virtual machine. I would not recommend testing on real hardware until you have a firm grasp of the concepts, or you have an old laptop you don't care about, and configure for full disk encryption, including boot on a BTRFS file system with snapshots and rollbacks, LUX2 encryption, secure boot, and TPM2, the whole package. So let's get going and take a quick look at how I've configured my VM. Here we are in Virt-Manager, the VM configuration, running on top of libvirt KVM. I'd like to draw your attention to the chipset we're using, Q35, firmware UEFI, specifically OVMF code 4M secboot, which is available on Fedora. We're running Fedora Silverblue as the host today. And let's click boot options. So I've got boot menu enabled and everything. We're booting from the SATA CD-ROM, the Arch Linux ISO. We've added manually TPM version 2.0, specifically model TIS TPM interface specification version 2.0, which is the max compatibility for our work today. Let's go ahead and go into the EFI firmware setup for our VM. Let's go to Device Manager, Secure Boot Configuration. Secure Boot mode will be custom mode. That is for going into setup mode once we delete PK. Secure boot will be disabled, that's right, because we're going into setup mode. Let's go into configuration one more time. As you can see, secure boot state is disabled now. We are in setup mode. Attempt secure boot is grayed out. So let's go and hit F10 and press Y to confirm. It saves the configuration. Let's escape out of here. Hit escape twice and select reset. Reset the platform. Now we're set up for Arch installation. We'll hit E because I like to edit the boot line and add video 1920 by 1080 to make best use of the screen real estate. It's booted up. IWCTL wireless instructions are there for laptop users. Let's set the font to Terminus 124 bold and check the platform size by cat sys firmware EFI firmware platform size, and it's 64-bit EFI platform, which is what we are looking for. bootctl, and we'll pipe it to grep-i secure, and as we can see, we've got Secure Boot disabled in setup mode, which is what we want, ready to enroll Secure Boot keys, which will come later in this video. Let's check for network connectivity. Google.com pings, good. So let's do, as usual, time date CTL, set-network time protocol is true. Let's erase the disk, block discard, force dev VDA, which is our virtual machine's target disk. Let's do an LSBLK. As you can see, it is blank, no partitions. So let's partition the disk with a GPT partition table, sgdisk. New partition. First partition will be our EFI partition of size 512 megs. The type will be hex EF00. We'll call it EFI system. Next, the rest of the disk will be partition 2, and the rest of the disk will be of type 8309 hex, which is of type LUX encrypted partition, or Linux LUX. So we'll call it, like I just said, Linux LUX. And the disk to partition will be our target disk for this virtual machine, which is /dev/VDA. Success. So let's print the partition table, sgdisk p dev VDA. So you can see we have two partitions, the EFI system, which is required for booting, and the rest of the disk is the encrypted root. So let's set it up. Crypt setup, LUX format with capital F, and will be of type LUX2. Again, check the Arch Wiki on how to set this up. I'm just following the instructions. So Cipher will be using AES-XTS-plain64. Very strong encryption. AES encryption is top level. The key size will be 512. Hash will be SHA 512. Again, this is from Arch Wiki and other sources. I've tested this out. This will work, at least in my private testing. PBKDF will be Argon 2ID. Very important for grub to boot an encrypted LUX2 partition. We'll label it crypt root. Again, our encrypted root partition. And the target will be dev VDA 2, the second partition. Remember, the first one, VDA 1, is the EFI partition. Are we sure? Yes, in all caps. Let's give ourselves a passphrase that we will hold secure and will not forget. Write it down and store it securely, because once you lose the passphrase, you lose access to your system. Almost impossible to get it back. So take good care of the passphrase. There we go. So let's do a crypt setup. Open /dev/VDA2, and we'll call it crypt root. Give it the passphrase we just made, and it's open. Excellent. So let's do an lsblk-f dev VDA. Looks like our partitioning configuration is correct. Chroot has its UUID. We'll use that later in this video. Let's format the EFI partition with mkfs fat32. We'll name it EFI. That's dev VDA1. For dev VDA2, let's format it as BTRFS. We'll label it Arch root. That's our encrypted root partition in BTRFS. And it'll be dev mapper cryptroot, which we just opened a step or two ago. Very good, 64 gigs. Plenty of room for our work. Let's mount it. Mount dev mapper cryptroot /mount. That's our BTRFS file system, which is encrypted. Next, let us do subvolume creations. BTRFS subvolume create /mount /at. That's the @ sign for the root subvolume. The same for the home subvolume, the log subvolume, the package subvolume for Arch Linux packages, and the .snapshots subvolume for Snapper and Friends. We'll do the same for the home directory, home_snapshots. Excellent. So let's do a BTRFS subvolume list /mount. You can see these are all the subvolumes we've created under /mount. Good. It's a good layout for snapshots and rollbacks, which is what we are intending to do. Let's unmount /mnt, and let's define the mount options, MO, in quotes, no access time. We'd like to have compression, transparent compression, Z standard level 1, and discard equals asynchronous. Cool. Now we can mount with the options, $curly braces MO, so that puts our options in there, mount options, comma, subvol equals @ that's the root subvolume, /dev /mapper /cryptroot /mnt, and hit return. Now that it's mounted, we'll create the mount directories for our rest of our subvolumes. So mkdir-p mount boot, home, var log, var cache, pacman, pkg for the packages, .snapshots, and curly braces. And we'll hit return or enter. Looking good. A couple of up arrows, and let's mount the home subvolume, the var log subvolume. Just keep hitting up arrow. Saves a lot of typing. The var cache, pacman, package subvolume, and the root.snapshots, where Snapper stores its snapshots. Mount that. And won't forget the EFI partition, dev VDA1. We'll mount that on /mount /boot. we'll make the mount point directory for home snapshots /mount/home/.snapshots. Let's mount it. Let's see if I can get this. There we go. Mount home.snapshots, and the subvolume is named home_snapshots, right? At home_snapshots is our subvolume we would like to use that we created earlier. Okay, let's check the mounts here to make sure, the real mounts that is, to make sure everything makes sense. And scanning this, it looks like it does make sense. So we've got space cache version 2 automatically inserted. I think it's superfluous with BTRFS and modern hardware, but there it is, so can't hurt, right? Let's quickly set our key map. So mecdir/mnt/etc, and then our key map, my key map in this case is US. Your key map may be different. We'll write the key map to mount etc virtualconsole.conf or vconsole. Good. Next, let's go ahead and Pacstrap -K/mount. Whoops, Pacstrap is spelled with a C, not a K. All right, let's start installing some packages in our new system. Base and base devel packages. Linux-LTS for long-term stability or support, stability probably. Linux LTS headers. I want to make this Arch install as stable as possible. Linux firmware. The microcode for Intel and AMD both. The system will select which one to use based on your hardware. BTRFS progs. Support programs for BTRFS or BTRFS. Crypt setup. Grub. Use the Grub bootloader. EFI Virt-Manager. Next, grub-BTRFS for bootable read-only snapshots in a grub submenu. I notify tools to watch the .snapshots directory for populating said submenu. We want Snapper and friends, including tracking package installs, Snapper and snappack. Secure boot, CTL control, and the TPM2 utilities, TPM2-TSS and TPM2-tools, \new line, network manager for networking. We need networking after all, right? Sudo, and then a couple of good text editors, Vim and Nano. Git, curl, and wget. Very handy to have. And htop and the manuals, database and man pages. In case you'd like to have documentation on the system. And off to the races we go. So I'll cut out most of this. Okay, all the packages are now installed or packstrapped into the system. Let's generate the file system table, genfs tab -U/mount, and we'll write that to mnt etc fs tab or file system table. Let's check out what genfs tab did. It looks like it did things correctly with the UUIDs and all the mount options. Everything's there. Okay, ready to Chroot into /mnt. We're now in the Chrooted environment. Let's set up our time zone. So I'm in US Pacific time zone. I'm on the west coast of the United States. So we'll link that to etc local time. Again, check zone info for your zone that you need to use. Hardware clock, sys to hardware clock. All right, and we'll edit etc locale.gen with nano. And I'd like to find and uncomment my locale, which is English US.utf-8. And there it is. I'll just uncomment this locale. Your locale may very well be different. Now we can run locale gen, and it detected en US UTF-8. Okay, let's set the language, echo, in quotes, lang equals en underscore US dot UTF-8. Close the quotes, and we'll write that to etc locale.conf. All right, next, let's set the host name. We'll call it ArchVM, also in quotes. We'll write ArchVM, the host name, to /etc/hostname. Next, let's nano etc hosts. Let's add a line for our new host, ArchVM. 127.0.1.1 will be archvm.localdomain, canonical ArchVM. Looking good. There's our etc host file. Let's give root account a password. Let's enter it twice. Okay, that works. Let's add a user account. User add, -m for home directory creation, -g add this user to wheel. Give this user bin bash shell, and my name, of course, is Stephen. I'll give myself a password. I'll enter a new password twice for good measure, so I don't mistype anything. Okay, let's sudo. Let's use the editor nano. And what I'd like to do is give the wheel group that I just added myself to sudo powers. I'll have to enter the password. I will not use the no password option. That's too insecure. So we're of group wheel, and we now are able to sudo and execute any command. Okay, let's edit make init copy io.conf. And the binaries, for good measure, I'd like to let it know that it needs BTRFS to work with the root file system. And under hooks, we'd like to add, as it says just a few lines above, we want to add sd-encrypt for an encrypted root file system that we have, right? So we let that configuration in, that module. We need that module. And it's done. So mkinit copy io -P. So let's building the image. And it's done. As you can see, sd-encrypt module is in there now. We'll ignore the warning. We don't even know what that is. At least I don't. Maybe you guys do. lsblk-f/dev/vda. So we want to capture the cryptroot UUID and get that and write to a file so we don't forget with block ID -s UUID-o value dev vda2, and we'll write the UUID to /temp/lux_UUID.text. That way we don't have to memorize this long UUID key. So there it is. It captured it correctly for Crypt-root. So you can see by direct comparison. So now what we can do is we can edit with nano etc default grub. And we can write out the command line for booting. rd.lux.name equals, and we do a Control R to insert from the file /temp/lux_uuid.txt. And voila, the UUID has been written for us. Equals Crypt-root. Good. rd.lux.options. That's root disk. RD is root disk, right? Options equals discard. And root equals /dev/mapper/cryptroot. And root flags equals the root subvolume, right? Root flags equals subvol equals @. Again, a root subvolume, and we'll make it read-writable. We'll boot read-writable, not read-only. Okay, looks good. Now, next, we want to enable CryptoDisk. grub_enable_CryptoDisk equals y. And we want to disable OS Prober because we will not address dual booting today. Very complicated, very risky. It's easy to erase your Windows partition if you're not careful. I haven't dual booted in a long time. Okay, so let's do grub-install. And the target will be x86 _64, 64-bit machine, -EFI. The EFI directory shall be /boot. The bootloader ID, what you will see in the boot menu, will be grub. You'll see grub in the main boot menu for the machine. Modules will include TPM, Trusted Platform Module. We need that. For enrolling the key later. So grub has to be made aware of the TPM that it has to refer to for unlocking the machine with a PIN. Disable shim lock because we're self-signing the secure boot. So grub make config -o boot grub.cfg. So that configuration file has been written. So grub is installed, configuration files written. Secure boot control status. So installed sbctl is not installed. Setup mode is enabled. Yes, we want setup mode. Secure boot is currently disabled. Vendor keys included are Microsoft. That's what we want because we're self-signing. sbctl create keys. So we created the owner key, machine owner key, mock, right? I believe that's what it is. And we got the UUID. So let's enroll the keys, including the Microsoft vendor keys with sbctl. Got a couple of problems. We got 2 immutable files, so we'll need to fix that with, as instructed, change attribute -i sys firmware EFI vars. Tab completion really helps here. And the other file, db-d tab, completes that file. Good. Now let's try to enroll the keys again. A couple of up arrows. And it enrolled the keys successfully with vendor keys from Microsoft. Excellent. So this is where the 4M comes in, right? 4 megs. You need the keys to the EFI variables. need storage for that. So let's sign our boot chain here. So we'll sign grub x64 EFI, the kernel. Third file we want to sign for secure boot is core.efi and grub.efi. So those 4 files have been signed using sbctl. We've signed it, which means it's valid, right? So sbctl verify shows all 4 files as signed. That's the entire boot chain that we want to make sure that secure boot will accept. Setup mode is now disabled. Microsoft has installed the keys. So let's enable with systemctl network manager for networking to be available after boot. We'll enable grub-BTRFS daemon for monitoring the snapshots directory and populating the snapshot submenu on grub. Let's enable the snapper timeline timer for auto snapshots every hour. I believe it's every hour. And cleanup timer. So our snapshots don't accumulate and slow the system down. Okay. Let's unmount all our directories, or mounts actually, from /mnt. Let's close the encrypted container. Crypt setup, close crypt root. Close it properly. All right. Let's reboot. Crossing fingers. Here we go. Grub comes up. We'll hit enter for Arch Linux. It's going to ask for the passphrase for our LUKS encrypted root, and accepted it. So now it gives us a login. Its login is root, the root password. Let's set font -D. Whoops, that's a little bit too big. Let's just stick with it. Like kindergarten, right? Big letters. At least you can read it, but I won't do this again. Sorry, folks. sbctl status. Look at that. Secure boot is enabled. Yay! Very good. And the owner GUID has been installed. Very nice. Let's go ahead and do a systemd -crypt enroll. Let's enroll our encryption key into TPM. Do this by setting tpm2-device equals auto. Let it figure out what the trusted platform module device actually is. Next, tpm2 with -pin, because we want to set a pin, alphanumeric pin, on boot to unlock the system. So we don't use the passphrase. This is an extra layer of protection because we can monitor with tpm2-PCRs equals 0 for firmware monitoring and 7 for secure boot state. So that'll lock the system down a little more. And that'll be a dev VDA2, which is our encrypted partition. Enter the current passphrase that we won't forget and won't lose, right? And next, we'll give it a nice longer, like 6 or 7 character alphanumeric pin, not just numeric. That's what I would recommend. Much harder to crack. And the TPM platform times out after too many failed attempts to pin unlock. Very secure, much more secure than not using TPM. Cool. Okay, so we've got a pin. So we've got to adjust our grub menu, grub command line rather. So let's nano it. And for the options, we've got to let it know that we're using TPM for unlocking. So TPM -2-device equals auto. And we'll let it know that we've given it a pin. We've enrolled a pin to unlock the system. TPM2-with-pin equals yes. All right, looks good. Just giving it a once over. Make sure I didn't mistype anything. All right, let's rebuild everything. So grub-mkconfig output to /boot/grub/grub.cfg. Excellent. No snapshots found. Yeah, we haven't done those yet. Comes later in this video. Stay tuned. Make init copy IO -P. Very good. So init ram fs has been created successfully. sbctl verify. Let's do a sanity check. It's not a P, it's a B. Secure boot. Looks like everything's checked. Green check mark. Everything is signed. Still, we haven't lost anything. This operation. So let's set up Snapper for root. So because it creates its own snapshots directory, let's unmount.snapshots so we can remove it. And then we can create the configuration for root. Snapper-c root configuration, right? Create -config/. That's our root. So let's remount everything. Mount-AV, and as you can see, .snapshots are successfully mounted because it referred to etc file system table, fs tab. Let's edit some settings here with nano. So etc snapper configs root. What I'd like to do is allow groups. We're part of the wheel group, right? Steven is part of the wheel group. So we want to add ourselves to work with the config. To sync the access control lists. I'm just going to follow what they have listed in Arch Wiki as best as my memory allows. I think 1800 for the min age for timeline. Hourly is 5, daily is 7, weekly is 0, monthly is 0, quarterly is 0, yearly is also 0. For the timeline cleanup, that's what they recommend. Who am I to judge? All right, let's do the same thing for the home.snapshots directory. Unmount it, remove it. Okay, and create the home directory's snapper configuration. So it'll recreate the /home/.snapshots directory automatically. If I didn't remove the directory first, it would fail with an error. So let's edit the configs for home, the snapper configs rather. Let's do the same thing basically. Let's add the wheel group. Oh, whoops. That's users. I want groups. Allow groups is wheel. So the wheel group is allowed to work with the config. Sync the access control lists equals yes. And we'll go ahead and adjust the limits for timeline cleanup, as we did before. 1800 minimum age. Hourly is 5, daily is 7, weekly is 2. Let's make monthly is 1, quarterly 0, yearly 0. Adjust as you see fit. All right. So snapper-c root, so we use the root configuration, will create a snapshot. We'll give the snapshot a description in quotes, base, install, end quote. Hit enter or return. There we go. Let's do the same thing for the home directory. All right. So next, before I reboot, let me do a snapper ls for root. As you can see, we have snapshot 1. It's a little mangled because the font size is too big. Again, my apologies. I promise I won't let that happen again. Do the same thing for home. Again, we have a single snapshot, base install. Cool, now we reboot. Let's go ahead and test the Arch Linux snapshots subdirectory. As you can see, grub BTRFS is working. iNotify is working. So it's monitoring for snapshots successfully. Okay, let's reboot to the main system. Now it's asking for a PIN. So enter our alphanumeric PIN. There it is. So we used the Trusted Platform module, version 2.0, to unlock the LUKS encrypted root file system. Cool. Now that we're in, let's do a quick update check. Looks like our Arch Linux system is fully updated. It's just the core, so it shouldn't be too much. Let's sbctl verify to make sure nothing's changed in our signing. Looks like the entire chain is signed. Very good. Let's sudo snapper, use the root configuration, and create a special snapshot with a description in quotes, pre-experiment. So let's see if we want to mess around with the system. So we kind of ruin the system and see if we can roll back and repair it, right? So we've got snapshot number 2 at the very bottom, description pre-experiment, and the date. Very good. So we've got it snapshotted. So now let's do something very naughty. Let's remove the file system table for the system. And that will remove the information that the system needs to mount its file systems, right? Okay, so let's try and boot and see what happens. Let's see how badly we damage the system. So let's enter our PIN to unlock Arch VM. It gives me the login. Let's log in as Steven. Password. Oop, we don't have a file system table anymore, so we don't know. Home Steven is no longer there. It's no longer mounted. It's broken. FS tab is blanked. Not there. Information is not there that we need. So let's fix the system by doing rollback the Arch way. So we go into Arch Linux snapshots. We'll select in reverse chronological order, right? Pre-experiment Linux LTS. So we're booting. We enter the PIN here. We are booting currently a read-only snapshot that we made. Snapshot number 2. Let's log in as Steven and the password, and we're in. So apparently we have a correctly functioning etc file system table, FS tab. Very good. So this is the snapshot we want to roll back to. So it's indicated, the currently booted snapshot is indicated with a little dash next to the 2. You can see in the bottom left of the snapshot table. So that's what we like to roll back to again. So let's do a sudo mount /dev/mapper/cryptroot on /mount. And then, so we're going to do this rollback the Arch way, right? So ls/mount, here are our subvolumes. So the current subvolume at is broken because it's got a missing file system table information. So we'll move /mount/at to /mount/at dot broken. And next, let's snapshot the known good one, the known good snapshot with sudo BTRFS Subvolumes snapshot /mnt/at dot snapshot /2 /snapshot /mnt/at. Good, so we have written in the correct file, the working root file system into our subvolume from snapshot 2. As you can see, etc tab exists again. So let's reboot. Normally, Arch Linux, enter the PIN, you can type it correctly. There it is. Log in as Steven, crossing fingers. Hopefully it's fixed. And it is. We have the file system back again. File system table. Very good. HTOP. There you go. So there you have it. A solid Arch Linux core install you can build on with desktops, Wi-Fi, printing, containerization, and so forth. sbctl should handle signing updates and kernel upgrades automatically. And you always have the recovery key or passphrase to fall back on should something happen to the TPM. The Arch Wiki will help with other recovery scenarios as well. I hope you found this little adventure useful. If so, smash the like button, comment below, and subscribe if you haven't already. Until next time, take care and have a lot of fun.